Parallel lines are lines that have the same slope. Okay, now parallel lines would never meet, right? Okay? So I'm going to say a little more than that, because if they are parallel and have the same y-intercept, let's say, then they're going to meet. They're going to be identical, right? So I'm going to say same slope, different y-intercept. Okay? Okay. These two lines should be parallel. These two lines have the same slope. So we're going to solve these as simultaneous equations. How do you solve these two equations as simultaneous equations?
Make them equal to each other?
Well, is there a multiple of the two equations that we could add, that we could eliminate one of the variables? Sorry?
2x?
Well, what multiple of what would I add to what?
Or what you do like, if you wanted to get like maybe 63 for the top for both. So then you would do like multiple of 9 for the first one and multiples of 7 for the second one.
Well, if we did that, that's a good idea, because you're thinking along the lines of what we've done, right? If you did a multiple of -9 here and 7 here, you get rid of the numbers over here, right? But you wouldn't get rid of x or y, because you would have like -18x, right? And 14y, so they wouldn't add up to 0, would they? Or not 14x. And you'd have -9y and 7y, which wouldn't add up to 0, right? You want one of your x's or y's to add up to 0.
So you want to subtract y from both of them?
Well, if you subtract one equation from the other, because you want to be subtracting or adding equations to one another.
Oh, okay.
Now, I don't like subtraction here, although if you're secure using it, it's valid. I like addition, because when you have subtraction, you can end up subtracting a negative, and that leads to sign errors. Okay? You're more prone to error. So I'm going to say I'm just going to add -1 times the first equation to the second. Okay? Well, that gives me -y equals -2x minus 7. That would be added to y equals 2x minus 9. Okay? Because I just multiplied every term of the first equation by -1, right? There it is, and there's my second equation. Now, if I add them, what's going to happen to y?
It's going to be 0.
Yeah, -y and y add up to 0, right?
Yeah, exactly. So does that.
So that's your 0
yeah,
that you need.
that's kind of the key. Okay? So when I add these, I get 0 here, right? Now, what do I get for my x's? Well, -2x added to 2x is
0.
by dang 0. And then what I get here, I get -16, right? Which is just saying that -16 is equal to 0, right? This cannot be. So there's no solution. And the lines don't meet. Now, if the lines don't meet, well, when I said what are parallel lines, the first thing somebody said was they don't meet. Well, that's equivalent to saying they're parallel, right? Okay? Okay. So, there's one way to verify the two lines are parallel by proving, well, they doesn't prove anything because this only is one example, right? But if you have the same number in front of x, when you have it in slope-intercept form, it's always going to happen that way. Okay? Your x, when your y's add up to 0, your x's have to add up to 0. And you're going to get, unless you have the same number here and here, you're going to get 0 equals something that isn't 0. Okay?